In 2013, the European Space Agency launched a rocket from a launch site in French Guiana and travelled some 1.5 million kilometres to reach its destination in orbit around the Sun. The spacecraft is called Gaia. Its mission is to make the largest, most precise three-dimensional map of the Milky Way ever attempted.
The science behind Gaia was recognised by everybody right from the start as something that mankind must do.
Gaia is going to be a revolution in fundamental astronomy. It's going to be a mission that's going to affect everything in astronomy.
Gaia is going to produce tomorrow's version of all the great star catalogues that have gone back in history to the very dawn of astronomy.
So it's our chance to understand how nature actually put together our night sky.
The Milky Way, the galaxy in which planet Earth soars around the Sun at 67,000 miles per hour, is so vast that it takes a beam of light 100,000 years to travel across it. It is home to more than 100 billion stars and maybe as many planets. It includes such exotic phenomena as star clusters, supernovae, gas clouds, supermassive black holes, and an elusive substance called dark matter. But it's not just those stars ablaze with nuclear fusion at their burning heart that we're interested in. Gaia is also looking for failed stars, brown dwarfs, stars that never truly ignited and are left adrift across space as interstellar itinerants. It will also provide an inventory of our solar system's asteroids and comets, from the near-Earth objects to those located in the furthest, frozen reaches of the outer solar system, revealing exoplanets as well as objects that could pose a threat to life here on Earth.
On the 25th of April 2018, detailed information on more than 1 billion stars will be made freely available to anyone, anywhere in the world. This is the second major data release from Gaia, based on 22 months of observations and about 500 billion individual measurements. It will be the richest star catalogue to date, including high-precision measurements of the positions, distance indicators and motions of 1.7 billion stars, and will lead to a huge number of discoveries about our home galaxy.
So what are the personal hopes and expectations for the Gaia mission? A mission 30 years in the making.
We're going to be able to walk through the universe and we're going to realise just exactly what we are compared to other people. We're going to find tens of thousands, if not hundreds of thousands of other planetary systems, some of which will be like our own, quite close. We'll be able to take pictures of those planets. We're going to discover the things we can't see, the dark matter. We will go beyond what we can see to be able to understand reality. And I think this is exactly the same transition that Captain Cook made. We go beyond our preconceptions to see, hey, this is what the world is like, guys, and we'll be able to just walk through it.
We will see the remnants, the debris streams, of the first shards that became what is today the Milky Way. We can run the process right back to the first things that ever happened. We will see the entire history of the Milky Way unfolding before our eyes.
We're going to discover completely new things. We're going to discover that stars are moving in ways that we think are impossible, and so we're going to learn completely new things about what happens. We're going to discover that there's actually an awful lot of matter there and hardly any there, and we'll be able to say, well, what is it then? How is that possible? So we'll learn a lot about elementary particle physics and possibly even about theories of gravity. So I think that's going to be the real dramatic change. The stuff that's going to come out of Gaia is not the spectacular science that we know it's going to do. It's the stuff that the questions we don't know how to answer.